All right, so let's do this. Let's go to number 3 on your notes from yesterday. Does everybody have that open? So it's the one where it says the graph shows the line y equals 1 plus 2x.
Yes.
Okay. So here's why we're going to do the notes first. I want us to get a little bit more practice writing the ordered pairs after we've solved the equation. And then I want you to go back, and we're going to do that for your workbook exercise 5. So instead of just solving for x and writing x equals whatever it was, we actually need to write the ordered pairs, okay? And yesterday, you guys were looking at the functions, and you were like, wait, where's y? I can't tell where y is. So I just want us to get a little bit more practice with that really quick. Okay, so on this one, and we didn't do this one yesterday, right? We did do this one? We just got to A. What was the answer for A? X equals, Livy T?
0.
Okay, X equals 0. Okay. All right, so if X equals 0, how do I write my ordered pair? Where is Y? Cruz? It is 1, yeah, exactly. And you can see that right here. So when you're looking for y, remember, y equals the function, right? So if it says that the function equals 1, then that equals y. All right, let's do b together. So b is 1 plus 2x equals -2. And you guys are saying we didn't do this yesterday, right? Okay, so I need to solve for x. The first thing I need to do is get 2x by itself. Remember, we're going to kind of work backwards in PEMDAS. So what do I need to do to both sides of the equation, Sydney? Yeah, I need to subtract 1. So I'm going to go 1 minus 1 plus 2x equals -2 minus 1. Now these guys cancel out, and I'm left with -2 minus 1. Since that's a subtraction problem, I'm going to go ahead and copy plus opposite that guy, because just to make it easier. And I've got 2x equals -3. Okay, now I want to solve for x. What do I do, Reagan? Yep, I need to get x by itself. So right now I've got 2x over here on the left. How do I get x by itself? No, I'm not going to subtract, because I've got 2 times x. If I subtract something, that's not going to affect my 2 times x at all. I would divide, exactly. So I'm going to divide both sides by 2. These cross cancel, and I'm left with x equals -3/2, which also equals -1.5 if we change that. Oh, I got the little pen trash there. Okay, now I want to write this as an ordered pair. Adele.
Well, I have a question.
Okay, go for it.
So up there, it's -3/2. Is that the same thing as like -3/2, like all in the parentheses?
Yes, it is. It doesn't matter where the negative is. If the negative is in the numerator, the whole thing is negative. If the negative is in the denominator, the whole thing is negative, right? Because really what I'm saying with a fraction is 3 divided by 2. And a negative divided by a positive is a negative, right? If I've got a negative in the numerator and a negative in the denominator, like say I'm dividing -3 divided by -2, I end up with a problem like that, then what do I have? I would have a positive. But one negative makes the whole thing negative. Okay, so my x equals -1.5. And Sydney, I want to write this as an ordered pair. Remember, I'm doing letter B up here. So what would my ordered pair look like? Yeah, and I can just keep it as a 1.5. I don't need to change it to a decimal. It would be -1.5, and then I look back up here to see what my y is, and my y was -2. And so there's my ordered pair. Okay. All right, let's do C. Are you guys starting to feel good about this? Okay, let's do C real quick. I don't know if I have enough room to do C. I'm gonna have to do C backwards and do it over here on the left. Okay, so I've got 1 plus 2x equals 1/2. All right. I need to solve for x, which means first I need to do my addition or subtraction. Grant, how do I get 2x by itself?
You're going to subtract 1 from both sides.
Good. I'm going to subtract 1 from both sides. Okay, and now these cancel. Those turn into 0, and I get 2x equals, and a 1/2 minus 1 is going to be a negative 1/2, right? Are we all on the same page there? Okay, now I want to get x alone. Livy, what do I do?
Divide it by 2.
Yes, I'm going to divide by 2, which happens to be the same as what?
Just 1.
Well, it is on the right, but what is dividing by 2 the same? If I multiply 2x by something, it would be the same as dividing it by 2. Okay, so what would that be? Because over here, when I'm looking at this number over here, I'm looking at the fact that I have a fraction, and I'm going to have to divide a fraction by 2, which means I'm going to have to end up multiplying. So let's just set it up that way to start. Lily, what should I multiply by, which would be the same as dividing by 2? No? Grant?
1/2.
1/2. If I multiply by 1/2, that's the same as dividing by 2. And then I can do that to both sides of the equation without messing with that fraction too much. So those cross cancel into 1, and my x equals what, Ben? What is 1/2 times 1/2? Yep, good. It's a negative 1/4 because I actually have a negative 1/2 times positive 1/2. Okay, so what does my ordered pair look like, Ian, for letter C?
It looks like negative 1/4.
Good. Now, the beauty of these, you guys, is that when you've got a graph provided for you like this, you can kind of check your work. So negative 1/4, I'm going to go over here on my x-axis, and I'm going to go to the left because it's negative. And here's 1/4, and I'm going to go up on my y-axis. They're dividing by halves instead of fourths, so I'm going to go up. And when I graphed that ordered pair, it hit my line, my function graph, and so I know that I was correct, right? And I can do the same thing and check over here too. Negative 1 and 1/2 is right here. Negative 2, I go down to negative 2. My dot hits the line, so I know I was correct. Adele.
So how do you know which direction to go in?
Well, do you see these negatives right here? Okay, and you know that this is the x-axis, right? We're not struggling with that at all. So negatives go to the left on the x-axis and down on the y-axis, and they're always going to be marked for you. Well, unless they aren't, I guess, unless you have to fill them in yourself. To the left and down. So x's that are negative go to the left, just like a number line, and y's that are negative, if you have a vertical number line, right, negatives would be lower. So you could think of it that way. Reagan?
So does the line just go straight across?
That line did.
Oh.
They don't all though. You can have all kinds of different slopes, you know, and it can go this way or it can go that way. So we'll talk more about that. You'll talk more about that in 7th grade. Okay, let's do this last problem from yesterday. It says the solutions of the equation 1/2 x equals k are negative integers, and k is also a negative integer. Write down 2 such equations solved using this graph. Okay, this sounds a little bit harder than it is, right? Okay, here's our function right here, y equals 3/4 x. All right, so we could just say this, 3/4 x. Remember what we were doing in the last couple problems where this was given to us? Now it's not given to us. We have to find a y for 3/4 x. So let's just find a y. Remember y equals 3/4 x, so we can do that. 3/4 x equals, let's pick a whole number right here. What's that y? If I trace it over, Libby T?
-6.
Okay, -6. And we could solve that and make sure x should equal -8, right? At 3/4 x equals -6. Is 3/4 of -8 -6, guys? Yeah, you can do that in your heads, right? Okay, let's do one more. 3/4 x equals, okay, let's pick another whole number for y. How about right here? What's y right there? Cruz?
3.
Yeah. Well, no, actually, what is it? It is a -3, good. Let's see what our x is. Our x is -4. Does 3/4 times -4 equal -3? Yeah. Okay, so that's all we did. This problem looks really hard and scary, but it's really not, is it? All you needed to do is go on, like use the line to find yourself a y and make sure that 3/4 of the x really does equal that y, and you're good to go on that. Okay, so here's what I wanted you to do on workbook exercise 5 before we grade it. So for all of those problems yesterday, and we did 158 to 159, right? Or was it 157, 158? Okay, so for numbers 1 through 4 on 157 to 158, you solved for x, right? X equals whatever. What I want you guys to do is take 2 minutes and go back and write the ordered pair for each time you solve x. For example, number 1, what did you guys get for x on number 1? Josie? Awesome. You got -3. The function is x plus 5 equals 2. So x is -3. What's y, Josie? Yeah. So just write that ordered pair, -3, comma 2. Do that for all the problems. Reagan?
I said x equals whatever and y equals whatever.
Then you're already done. Good job. If you already wrote the ordered pair for all of these problems, then you did the right thing. That's what I'm going to grade. We're going to grade for in just a minute. Okay. Yeah.
So do you want us to box the order pair?
No, I want them in just in parentheses. Well, you could just to make sure, but it should be pretty
Do
visible.
we have to write the y?
Well, you will write it inside the ordered pair, right? So like, for example, number 1 was -3, comma 2 in parentheses. So by writing it that way, you are writing the y, you're just not writing y equals. Okay. So just 2 minutes to do that. If you guys are watching this video today, I want you guys to add that to your workbook exercise 1, those first 2 pages. And then going forward, when I assign the rest of workbook exercise 1, you guys are going to make sure that you put your answers in the form of ordered pairs for each one of those questions. There we go. Recording. Okay. Thank you very much. Yeah. It's quite an impressive accomplishment that I found the actual button on the, okay. So what I want you guys to do is we're going to work through practice C. So pages 189 to 190. And you're doing this on a lined sheet of paper and you're working in your textbook. And I don't know if you'll get through all of it. So let's just do as much as we can. Number 9B is going to be a little bit tricky. So if you get that far, then you're probably ready to solve 9B. But I'm going to give you guys about 10 minutes to work, and then we'll start going through problems. We'll start going through answers, okay? So 189 to 190, practice C on a lined sheet of paper. Remember to make sure that you keep your work really super nice and neat on that sheet of paper, okay? All right, so we're going over answers for practice C, pages 189 to 190. And oh, it would help if you had a visual aid up there, wouldn't it? There we go. Okay. All right, so number 1A, x equals -2. 1B, x equals 2. Okay, guys, go ahead and raise your hand and stop me if any of these you're like, I am way off and off. I don't know how. If you just are like off on one, then maybe not. Okay, Lily.
Well, on B, I got -4. Yeah.
Okay, let me show you why you got -4. Because you didn't copy plus opposite this. So we have x plus 3, right? Okay, let's take a look. If we have x plus 3, that means we need to subtract 3 from both sides. So we end up with x plus 3 minus 3. Now we need to say minus 3 over here on the right. Okay, which is really the same as saying plus -3. Oh, that's why. Yeah. So wait, who didn't copy plus opposite? Me? Okay, well, let's adjust that then. All right. Oh, I'm cracking myself up today. All right. Does that look better, guys? I love it when I start correcting you guys and then I'm like, oh, but actually, but actually, I'm really wrong right there. Nora, you're never going to answer negative X. Always change it to positive X. But X doesn't equal 4, it equals -4. I just showed you why. Okay. C, X equals -8. Okay, there's not mutiny, so I'm assuming I'm right there. D and X equals -13. Okay, awesome. Number 2, X equals 7. B, X equals -1. C, X equals 0, and D, X equals 1. What did I do? Lily.
Well, I got all of those.
All right, well, let's check them. X minus 3 plus 3. So on the, oh, okay, this is, I don't, so what you need to do in number 2 now is add 3 to each side.
Oh, I see.
So, yeah, no, we're already subtracting 3. So we've got to add 3 to make those 0. Okay, so if you go back and do that, you'll probably get the right answers. Okay, 3a, X equals 3. B, X equals -4. 4a, X equals -6, and 4b, X equals -8. How many of us got that far? Okay, awesome. I'll show you the rest of the problems for 5 and 6, and then we'll make sure we do 7. How many of you got all the way through like 7? Okay. So 5, A, X equals -15. 5B, X equals -8. How did we do with those? Okay, good. 6A, X equals -1. This was another one of those where you had 4 minus X. Those are tricky, you guys. And so you can go back to that number line method that I showed you at the beginning of this unit. But on this one, we have a +4, so we have to subtract 4 from both sides. And we end up with -X equals 1. Then we have to multiply both sides by -1 so that we end up with just X. X equals -1. Okay, and then B, X equals -4. Lily.
What was 2B?
2B. 2B was X equals -1. All right, 7. Okay, how many of us did 7? Okay, awesome. Well, if you didn't, let's do it together really quickly. So we've got a graph in front of us that looks like this. Okay, and so what we want to do is we want to solve for X for all of these, and then we're going to write as ordered pairs. So letter A, our function is, the function is always Y equals 4 minus X. So remember, whatever 4 minus X equals, that's going to be our Y. So in each one of those cases, you can just write Y above the, whatever is after the equal sign. So 4 minus X equals 5. So we need to subtract 4 from both sides. That looks like this. 4 minus X equals 5 minus 4. I'm missing a couple lines of work here, guys. So -X equals 1. Then I would multiply both sides by -1 to get X equals -1. So my ordered pair would look like -1, 5. Sydney?
Why would you subtract?
Why would I subtract 4 up in this line of work?
Yeah.
Okay, the reason I subtract 4 is because I want X by itself. And we want to get all the other numbers and coefficients out of there so that we're just left with X equals something. So the way we do that systematically is we're going to start with addition and subtraction. So any term that's in the function or in the equation up here, it's not attached to the X, like I've got this 4 hanging out right here. I'm going to get rid of that 4 by subtracting 4 from both sides. And then that makes that turn into 0. Now I just have like X with nothing with it, right? X plus 0. But whatever I do over here on the left, I've got to do it on the right because that equal sign needs to do its job. So I'm left with -X equals 5 minus 4, which is 1. Well, I can't have a negative X in my ordered pair. That doesn't make sense. I can have a negative number, but X has to represent either a negative or a positive. So if I have a negative and then times an X, it's gonna like be the opposite of whatever my X ends up being, and that's not right. So I need to just tell what my X is by getting that negative out of there. And to do that, I'm multiplying both sides by -1. Or you can think of it as just take the opposite of whatever the negative X equals. Yeah, go ahead.
Then why did on like 2 did we add?
Right here.
Yeah.
The reason we added 3 is because our starting equation said X minus 3 equals 4. So in order to get rid of this number that's hanging out right there, I need for that to end up being a 0 so that I have X either, just X plus 0 on that side. Does that make sense? So I have to add 3 in that case instead of subtract 3. And really you can think of everything like an addition problem. This is really the same as saying X plus -3, right? If we wanted that -3 to get up to 0, we would add a +3. So that's what we're doing. Okay. All right. I think we're out of time. So let's just skip over just turn your textbook over to page 190. And let's look at 9B. So 9A is just you're solving just like you have been for all the other problems that we did. All right, 9B says the equations 2x plus 1 equals k and 1 minus 3x equals k have the same solution. Find the value of k. Oops, k does not equal 0. That's wrong. So what we would do is we're just going to use the graph to solve this, you guys. K is equal to a y value, right? Okay, because this is, so we've got 2x plus 1 equals whatever y is. So where on our graph is y the same for both of those function lines? Ian? Yeah, right here, just right where they intersect. And so that's the only place where we can find the value of k. So k would be equal to 1 because that's where those lines intersect. So that problem seems really hard, like you're gonna have to do a lot of math, but really all you have to do is look at the graph. It's super easy. Okay, and that's how we would answer it, is just k equals 1. All right, so for tonight, guys, you're gonna do the rest of workbook exercise 5. Number 8 is a bonus. And all of your answers need to be written as ordered pairs. Okay, so just like what I had you guys do today, write ordered pairs for everything and you should be good to go.